folks from the Global Transformation Office. Today we have Andrew Clay Shafer here. Again, this is his second round on our Fridays with GTO, and he's going to talk a little bit about cloud native operating models and what that means to him. I kind of love the topic, but the title, but don't quite know exactly what he's going to come up with today. So Andrew, take it away, and we'll have live Q&A at the end of this.
Yeah, neither do I. I never know what I'm talking about. If you want to jump in and have me explore or explain anything, it doesn't have to be just me monologuing. If you
Sounds like a
want
plan.
clarity on any of this, so jump in.
Will do.
That goes for everyone. So this is just a quick kind of framing. So I had a very privileged career in a sense to see some of the things and participate in some of the things that I have for the last decade, and that gave me certain framing to talk about some of this stuff. And I would say that the pattern of my career has really been trying to take the things that I've seen work and put them together and share them in a way that other people can make them work too. So going back to the last 10 years, it's really been focused on open source infrastructure and projects back to Puppet, OpenStack, and now more and more Kubernetes. In parallel to that, I was part of organizing these DevOps days globally, and these communities of practice around Velocity Conference. And so those conversations and being part of those projects gave me what I think is a pretty unique vantage point to try to help these the customers and the communities around these different projects. So the overarching theme of lots of this is there's the code and there's the Git repos, and then there's what do you actually do with that, and how do you make it work. And so this is me trying to distill some of the thoughts and conversations I've had in the last few months and try to at least remove some confusion. I'm not sure I'm going to answer everyone's question. In some ways, my hope is that you have the ability to ask better questions at the end of this more than you have all the answers. So from there, the thing that I want people to realize, or that I think people actually feel viscerally, is there's this tension between these old ways of doing things, processes, technology, and sort of the new way of doing things, right? And that's a little bit of an oversimplification, but the thing that I would point out, and I think if you've tried to do this in a real sense, especially in a large organization, that if you have adopted something like a container platform, not that we know of any, and you're managing it with your old processes, and you're managing it, kind of with the old mindsets, then the rate limiting or the upper bound of how successful you can be with that new technology is limited by the fact that you're managing it in these old ways. And so the new tools sort of require, or not necessarily require, but they're optimized by new thoughts and new behaviors. So in this old world, we used to manage servers, and we would brag as sysadmins about the uptime on these servers that have been up forever and not restarted. And now we live in a world where containers might be, the life of a container by design might be on the order of seconds, minutes, certainly not days or years like we used to be so proud of. The other thing that's happening is you're getting more and more of this work that is automation enforced by APIs and not done by human toil. And that's the theme I'm going to come back to over and over. And so the other thing I think is worth pointing out, particularly in enterprises as they adopt these things, is that these patterns of IT and framing it as a cost center and having these processes is really rooted in supporting business as usual, where the IT is a secondary consideration to whatever that kind of core business was. And it's not that you want to necessarily forget who you are, but in the new world, IT and technology is much more central. And if you look at the market dynamics and the performance of the top end of the market, it's sort of dominated by the the FANG companies or the cloud companies, whatever you want to call them, where they're using technology not to support business as usual, but technology is the business, right? And so that's a kind of fundamental mind shift as well. So here's some questions, and like I said, I'm not necessarily going to answer questions, but I'm kind of going to answer questions, and we'll have more questions by the end. So this is relevant to this narrative around, you know, what we've seen over the last 10 years and what people are trying to do. And if you look at what I see, and you know, this is across the Kubernetes community in general, and definitely in the OpenShift community, is that people are in very different places with respect to how they take that technology and put it into their workflows, into their, you know, behaviors, and where they let it change their behaviors or not. And you see this in a lot of cases. They're adopting a new technology, but they have a process that came from how they manage their VMs, that came from how they manage their bare metal, and they haven't really redone or rethought from first principles what promises they're able to keep with those processes, you know, versus the opportunity that they're losing by kind of slowing themselves down. So I'm going to give you my definition, and this is, you know, there's like this whole subgenre of people debating the definition of words, but this is Andrew's version of what DevOps is. And you know, I've given this or said this on stage multiple times over the last few years. To me, and this is in the framing of software is eating the world, right? So there's this notion that software is eating the world, and to me that means software is going to optimize everything that it can over some, you know, timeline. And to me, DevOps is really about optimizing that human experience and performance of operating software, doing it with software. So that's sort of the software eating the world, and then recognizing these are social technical systems. It's not just the technology by itself. It's for us, by us, and so you're going to do this work with humans. And so this is like, you know, the last 10 years of my career is going around the world and talking about and helping people try to adopt these processes and these technologies. So at the same time, in parallel to this, there's this conversation, and I'm going to come back to SRE and DevOps in a few ways over the next few minutes, 30 minutes or whatever. But this is the quote unquote beginning. You know, this person coined the term SRE at Google, and this is a quote from Benjamin. What happens, SRE is what happens when a software engineer is tasked with that used to be called operations. And I'm going to get,
So I'm going to pause you just for a second. You're saying SREs, and some people might not know what it stands for. Software.
So site reliability engineering is you know, quote unquote the Google implementation of DevOps. There's free books you can read. So if you Google SRE book, you'll get to a link that is hosted by Google that has all of the text for free. If you like to buy you know, dead trees or whatever, there's hard copies as well. There's the SRE, the original SRE book was 2016, which I'm going to come back to some of the points from that book. And then there's an SRE workbook that came out 2018, 2018, I think, that I wrote the foreword for that book that has, or one of the forewords, the other one's Mark Burgess, talking about, so the first one is really SRE as Google envisions SRE itself aspirationally inside Google. And some of that's a little bit sort of navel gazing in like Google specific. And, yep. And then the second workbook is an attempt, and it's mostly Google people, but there's some more collaboration outside Google to bring SRE in practice in a practical way to like share some of those practices. And this isn't necessarily all about SRE, but there's going to be some more SRE content and like kind of talking about some of these models. So why does this even matter? Like who like, okay, so there's words and you have DevOps, you have SRE, like what does it actually do? And it's interesting watching, you know, this is a common theme with, you know, agile, DevOps, transformation, SRE, where you see lots of people adopt the vocabulary and maybe change their titles, but they don't really change their process. So let's try to do better than that. So the why, in my opinion, for both these things, and I would argue, you know, DevOps and SRE are essentially the same phenomena, and that's part of the theme that I bring out in the foreword I wrote for that book. But really what's happening here is that you have these new models being created as part of an evolutionary pressure to deliver systems that are, flexible, adaptable, changeable at scale with high levels of reliability, right? So reliability is even in the name of the way that Google framed it for themselves. So these models together with the technology are what enable all these things that we kind of take for granted, right? So there's lots of things that we take for granted. We all walk around with these little supercomputers in our pocket, and we sort of think, and for the most part, Google's going to be available, Gmail's going to be available, Facebook's going to be available. Twitter has a few bad days now and then, but like it's been pretty good lately, right? So we take this stuff as like the kind of baseline ambient experience that we all have, and then when we get into the sort of enterprise IT, that's not always the case for all of us in terms of what we can deliver from a reliability perspective. And part of my argument here is that there's certainly technology that can help you improve those promises you keep, but there's also this sort of human workflow aspect that has a huge impact on building those reliable, resilient systems. So I'm going to kind of walk through a few things. What I'm going to talk about platform patterns. Then I'm going to kind of compare and contrast this notion of you build it, you run it, which is sort of famously, the Amazon way of doing this, which is slightly different from the Google way, but I'm going to kind of show how they're not that different in some ways, and then go back to the SRE, more specific language and sort of practices. So this is me drawing shapes on a slide, and the argument I'm trying to make here, and this is, again, oversimplification for the sake of making a point, is that in the traditional IT life cycle, that you have these stovepipe infrastructure with purpose-built, built up to deploy a particular app, right? So projects would start with a PO, and then there's some life cycle to get the hardware in the data center. That might be months. Then at some point there's operating system, and you start putting it together, and then you eventually get an app, and that's long-lived and tied together, so you kind of have to refresh them. And then we get a little better as we get to some automation and virtualization. But what you see happening in the cloud native organizations is they collapse a lot of the complexity of the infrastructure layers, and then they want to spend more and more of their quote unquote complexity budget delivering value at the application. So if you go to a lot of enterprise data centers or colos or whatever, you walk around and every rack has slightly different configuration of gear. If you go to cloud native quote unquote data center, and there's the open hardware stuff, and then there's the Google stuff. Not all of it's open, whatever. But if you get an opportunity to go see one of these data centers, there's really, really like football field sized data centers filled with racks and racks of identical gear, because they're really collapsing the complexity of what they have to manage. I think it's also worth noting here when you start talking about, so people say things like the ratio of the machines that are managed by these kind of sysadmins at one of these companies versus what you see in the enterprise, and a lot of that ratio is coming from collapsing that complexity. It's easier to manage 1,000 things that are identical than it is to manage, in some cases, 10 things that are not identical, right? So like a lot of that ratio and that efficiency comes from collapsing that complexity at the bottom of the stack. So this is a pattern you see over and over. And then you look at what comes up the stack into kind of what I'll call the platform services. Every single one of these organizations, and there's a list of more that built various aspects of built this sort of self-service provisioning platform for their developers to be able to do work, right? And Google's been very public about how they did that and what they did that. Amazon hasn't necessarily been public, but they made some aspects of what they learned and built very public by launching EC2 in 2006. And then Google, obviously everyone's trying to kind of play the cloud provider game now, taking all those lessons from that. So everyone built these things from first principles, slightly different ways, but they built them because they had to. There was no community project that was helping solve these things. But if you go look at what Netflix built, circa, I'd say 2000, 10ish. Like it basically looks like kind of Kubernetes-esque, but on top of VMs, on top of Amazon. So, you have something where you push a thing. They basically baked images just like we bake containers. They're AMIs. They had these Java projects. You can walk through the open source projects from Netflix, and you can see the routing and the log aggregation and all these pieces that were the Netflix Java specific way of doing that. And now you can map a lot of those same sorts of capabilities straight to CNCF projects, and so then we don't all need to rebuild these things from scratch. So this I'm just going to read. Go ahead.
You go back to that slide just for a second, because it's interesting. Around 2010, they did come out with platforms there, but just prior to that was when like 1,000 platforms as a services bloomed to use their infrastructure. So it was almost like they saw the need for a platform from the thousands of small platform as a services and offerings that were there. So that kind of drove them to do some uniformity there.
I mean, I would frame it slightly different. Like Netflix was doing those platform as a service things before there were the public platform as a service, right?
Yeah. We saw like, I don't know, there was a platform as a service for Perl stuff for everybody
Yeah.
had their own platform as a service, and what Amazon and Google really did was kind of unified that and made that available as a product on their
Well,
platform.
I think the first thing they did, because a lot of the platform as a service, this is like a deeper philosophical thing, that a lot of the platform as a service failed, right?
Yeah. Oh,
And
absolutely.
Google's first foray into cloud as a service offering was App Engine, which was a platform as a service that didn't appeal to a lot of people because they had made it so Google specific. You had to
Yeah.
basically remap the concepts you were used to onto Bigtable or whatever, the kind of the Google version of it, and they could keep all these promises about scale, but it wasn't necessarily the paradigm people wanted to use. So there's like another hour-long conversation about the evolution of.
That someday we'll tease that out, because the evolution
So
of
like
those.
the insight that Amazon had is they actually went a step down, right? And they gave you, okay, like here you can basically run OSs. Like the first version of EC2 was you can, here's 3 different things. You could have any VM you want as long as it's black. They only had 3 different sizes.
Mhm.
The other things that came before that is also interesting is the first cloud service from Amazon was the Q,
Yeah. Oh, wow.
SQS, right?
Yep.
And
Yep.
then S3. So anyway, there's like a whole another hour of talking about the evolution of this stuff.
Cool. Well,
So this, I'm just gonna read this out loud, and there's a reveal, but all this stuff sounds great, right? So remove friction from product development, high trust, low process, no handoff between teams. Do not do your own undifferentiated heavy lifting. Use simple patterns automated by tooling. Self-service cloud makes impossible things instant. So these are great words, sounds great to me. I did not write them. These are actually stolen word for word from conference presentation on the Netflix lesson learned by Adrian Cocroft when he used to work for Netflix, right? So to me, when you're talking about something like OpenShift and the platform and the goals that you have as an organization, it should map more or less to this, like as you can, right? And obviously we're all in different parts of that journey, but I don't think a lot of organizations never necessarily have this as a North Star, or at least their behaviors don't indicate that. And so the more that we can help each other get there, then I think the better off everyone's going to be. Because I like nice things. I want you to have nice things too. So I kind of made this point earlier, but this cloud conversation evolved from the lessons learned building, operating these services. And that's key here. So these are services, software services, platform services, infrastructure services. Now the bad thing is you actually have to operate those. Like they don't operate themselves, right? And this is where some of the modeling or the operating models can come in, is because you can make different choices about who's accountable for each one of these things in terms of the operations. So what is operations? We keep saying this word, and there's like this whole body of operations that means something in a business context that's totally different than what I'm talking about today. But for me, operations is really about, you know, the system operations and building this kind of technical infrastructure and delivering things that way. So, you know, this is the DevOps days, this is the Velocity conference, this is the SRE book, like all these things are part of it, right? So it's like metrics, pretty much key to understanding what's going on. Now you have some stuff you can hopefully determine things are good or bad, and when things are bad, you hopefully alert people. When things need to change, you hopefully aren't doing everything manually. Got some automation. There's a lot of what I consider operations that really comes down to having a mental understanding of the system and getting into the middle of it when things are going wrong and troubleshooting and doing the right thing. And then hopefully you learn something from that and can make, you know, better changes or better automation, better monitoring for the next time. And you know, there's again, this could be its own like 12-hour lecture series about each one of these topics basically, but this is the focus of DevOps Days conversations for the last 10 years, and there's lots of meaningful stuff available for you to go dig into that, but these are kind of like a baseline set of capabilities. So this is a slide from 2007, and I use it in a lot of conversations and a lot of presentations. It was made by one of my friends who at the time worked at Amazon, and he was talking about, so this is sort of the golden age of Puppet and coming into like the beginning of DevOps conversations. So you have traditional operations on one side and kind of the new quote unquote secret sauce operations on the other side. And the argument here is that the colors on the graph represent quote unquote toil. So the humans doing work. So the number of hours of work to maintain a system. And then the x-axis is representing the scale or the system scaling up. So you're adding servers to the system. And those numbers seem laughable now. Like, oh my gosh, 20 servers. But at the time it seemed like a big deal. So like the argument here that Jesse is making, and you could go read this archive from 2007. I wrote another kind of follow-up to it in 2010 about revisiting, but the short version of this is that there's a new way of doing things that if you put kind of in the design, the effort, that you have this different curve for the amount of human toil that's required to manage those systems as they scale. And this is 2007. So in 2020, we should be able to compress that curve even more given the platforms and the tools that we have available to us today. But the thing I want to draw here and as we go into the rest of it is this notion that operations is this secret sauce competitive advantage. And I would argue this is the defining advantage of the cloud natives is their operational excellence. So this is 2006, and this is a pretty famous interview too. I'll just read it as well. The traditional model is that you take your software to the wall that separates development operations and throw it over and then forget about it. Not at Amazon, you build it, you run it. This brings developers into contact with the day-to-day operation of their software. It also brings them into day-to-day contact with the customer. This customer feedback loop is essential for improving the quality of service. So this is an interesting quote in time. This is the year EC2 is launched, basically 2006, and this is 3 years before DevOps is a word. But that sounds suspiciously like, you know, a lot of the conversations people had in the DevOps community. And just to kind of give a shout out to what I mean when I talk about DevOps, and you know, if you Google, there's hours of me saying things about these words, but you basically have this kind of community of practice that evolves, having conversations, and these are the quote unquote elements or what have you of these DevOps conversations. This is a blog post that John and Damon wrote after the first DevOps days in the US. They identified culture, automation, metrics, and sharing, and then Jez in like, you know, very, very quickly after that added lean with this notion of continuous improvement, Kaizen. And so like there's no shortage of DevOps content online, but this is sort of a framing for some of this other stuff we're talking about with the capabilities. So going back to this notion of you build it, you run it, what Werner's saying when he says you build it, you run it, the software teams are not building up all of these other services. Those exist for them inside of Amazon in 2006 for a developer or development team to get access to provision infrastructure was an API. Provision and database was an API, right? So you've got all this built-in platform and infrastructure services available to the developer. The developers are not building those, they're not running those. They have insight into them. But what Werner actually means for the quote unquote two pizza team to run their software is that they run their software and then they have all these other things that are taken care of for them by those other responsibilities. So that's something that I think sometimes gets lost in translation, where you see groups of people who are like, oh, you build it, you run it. And it's like, oh, well, now you got to install OSs, and you giving developers who may not have that kind of context and expertise a bunch of things that they're not necessarily prepared to do well. And so there is some value to that sort of specification stratification. So this is Google. SRE is not really part of the lexicon until 2016. So this is 10 years after that Werner quote. And I already kind of said this earlier, but this is essentially Google's DevOps implementation. And one of the reasons I shared this a minute ago is if you go through and read this book, like they pretty much check off all these boxes. You can kind of go that, you can read it for free, search SRE book. And this is my recommendation for everyone. Good DevOps copy, great DevOps steel. So wherever you find good ideas, you should take full advantage of them. And then the rest of this, or for the next section of this, I'm going to talk more specifics about SRE kind of in practice. And this is straight from the book. So this is the Dickerson's hierarchy of reliability from the SRE book. And here you can see the foundation of reliability from a Google perspective is monitoring. Right, and so then you have monitoring. You can figure out a little bit more about what's going on. Now you know something's wrong, so then you respond to incidents. Now, okay, like we respond to those incidents. We learn some things. We do some analysis to that. That kind of goes back into it, and then at the very top you get up to this notion of the product. Like why does this infrastructure even exist? And I'm not going to go through. I mean, the SRE book's 500-page book, so. For now, we'll just keep going in it. But I'm going to come back to this notion of monitoring as the central thing. So this, if anyone hasn't read the Borg paper, so I think the Borg paper, when is it, like 2015, they published this paper about Borg, and it talks about the evolution of Borg, and it talks about Kubernetes and some of this stuff. I also think it's kind of fun to point out and reflect on that in the 2009, 2010 timeframe, if you had a conversation with someone who worked at Google and you tried to get them to talk about Borg, then they would stop talking to you, right? So there's like this shift in the understanding of what is a competitive advantage, and that's a fundamental shift, and you see the Kubernetes and the ecosystem that was built around that. As a reflection of them reframing some of those things that they thought were secrets to them. So the Borg paper has this gold nugget that I think everyone misses. They get focused on container scheduling and like fancy algorithms. So this is straight from that paper. Almost every task run under Borg contains a built-in HTTP server that publishes information about the health of the task and thousands of performance metrics. And I have a standing wager, and I don't think I'll ever lose this, that you will get more operational benefit from building instrumentation, observability into your software, into your applications, into your services, than you will navel gazing on optimizing your container scheduling infrastructure, right? So
telemetry is everything.
Monitoring is the foundation of reliability from Google's perspective, right? So people miss this, but what are you going to do? Monitor, monitor, monitor. So this is all straight from the book, and we don't necessarily need to go through it in depth, but service level terminology, you have to build up to that to get to the talk about SLOs. And to me, SLOs are the defining feature of SRE, so it's worth building it up. So you have service level indicators, which are basically, now you have some monitoring. You can look at your stuff and say, okay, like here's the service level. And then you set service level objectives, which we'll talk about a bit more. And then that is not to be confused with service level agreements, which tend to be contractual and maybe, imply things about money and that kind of stuff. So service level objective is, and I'll talk a bit more about it, but it's basically this three-way contract. So just for the sake of thinking about it and not necessarily to be exhaustive here, every service is different. And in the book, there's a thoughtful discussion about what types of service level indicators and service level objectives might be appropriate for the types of things you're building, right? So user-facing systems are slightly different than storage systems. And so finding a way to kind of map what you're doing, not like a cookie cutter paint by the dots, but like be thoughtful about what a service level should mean for the particular service that you're running. And then, you know, what kind of, that drives a bunch of decisions about monitoring. And then this is also straight from the SRE book, but this is the kind of the golden signals. The 4 golden signals, according to Google's SRE book, are latency, traffic, errors, and saturation. And so if you are not monitoring those things right now, this is maybe a good opportunity to steal a good idea from someone else, and then think very hard about, you know, if you're not monitoring this stuff now, why not? And if you aren't, then what would it take to get this kind of information and start to think about the, you know, the meaning of each of these for your particular context. Now that you have SLIs and you can measure these things, then you move on to this notion of an SLO. So the service level objective, and to me, this is sort of the defining quality of SRE is really centered on SLOs and this contract. So you say, you know, we want this many 9s or this many whatever for these particular indicators, and that establishes an error budget. You don't necessarily want to have a single dimension for an SLO on a service, but you also don't want to make it too complicated. And, you know, this last point here is worth pointing out that progress is more important than perfection, right? So what do we have measured, and what are we kind of looking at today, and what can we do to improve that system and make it so that it's better tomorrow? It's more important than getting it perfect. So this SLO is really a 3-way contract between the developers, the business, and the operations. So the business is saying reliability is important to us. If this thing is not available, then it's not delivering value. Developers are pushing, you know, the code, and then operations is responsible for that reliability, or the SRE. And so what that establishes is this notion of a service level objective, which gives you an error budget. And then in the context of the error budget, the idea, at least from the aspirational kind of perfected version at Google, is that you can do things with that error budget. So I think it's worth pointing out 100% is not realistic. I would argue it's actually impossible as you get to these 9. So now you have an error budget established. You can talk about this acceptable level of unreliability, right? And for some things that might be minutes or seconds, and especially gets interesting when you talk about building these services that can operate with continuous partial failure, right? So you have some isolation, some concurrency, so that some fraction of your system can be down. And you know, that dovetails into another kind of interesting subgenre of DevOps around chaos engineering and injecting failures, and that's all good fun, but not what we're going to talk about today. So now you have SLO, you have these consequences. So when you're below your error budget in like the perfected version of this, you have this notion of the developers have self-service access, they could do all this stuff. When you blow your budget, we'll go to this next slide, then it changes the dynamic of these things. So in the quote unquote aspirational Google sense of this, when you're below your error budget for reliability, the dev team, they deliver features. If you blow your error budget, then the dev team capacity for work is focused on creating more reliability. And this is something lots of orgs balk, like they have a hard time, and there's a bunch of like political and organizational reasons why this is hard. You know, one, you don't have SLIs in the first place in a lot of places, but 2, like getting this idea that, oh, we're not going to work on features because stuff's unreliable, just kind of like seems to blow people's minds. But this to me is like the defining feature of true SRE in practice, at least as it's aspirationally espoused by Google. And then moving forward, so you have this notion of SRE at Google. When you look behind the covers, like not every project at Google gets SRE. They actually start out very close in very similar to the model that happens at Amazon, and then they earn the right to have SRE support by being, you know, demonstrating their value, and then SRE take over the operational responsibility, the call, the troubleshooting, after services have gone through the production reliability review and the application reliability review to kind of retool the architecture to match with the promises of the SLO that the SREs are signing up to keep. And so just to make this point, this is something I think gets lost because people see the SRE and they're like, oh, it's just like traditional operations. You know, we just have like, we'll just change the name of our sysadmins to SRE. The SRE are not there to take toil away from the software engineers. The SRE are there to drive toil out of the system. And so that's the whole point of this, you know, one, the E part of SRE, and two, this reliability assessment to take the burden of it. And at least aspirationally from the book, there's this notion of a toil that's being created by a service. And according to the book, if you, as a software engineering team, exceed the SLO air budget too much, then the SRE have the right to push all of the operational burden back onto the software team. So it's like, you can't get your stuff together, you're causing me a lot of problems in work. It's like, okay, now it's all your problem until you get back into, you know, if you need to go outside to use the bathroom, like you can't be a puppy, right? And you got to go, we got to train you to do this right. So there's like a little bit of a power dynamic where the SRE could push the operational burden back on the software engineers. I think it's also worth pointing out, and I had a lot of philosophical conversation with people at Google about this, but SRE are effectively the architects of Google's platform, those platform services and those data services in particular. And in a sense, they're also essentially product managers there. So this is straight from the book as well. SRE builds framework modules to implement canonical solutions for the concerned production area. As a result, development teams can focus on the business logic because the framework already takes care of correct infrastructure use. So when you're thinking about adopting a container platform and kind of building up these platform services for your own organization, I think you know, maybe you're not going to adopt the SRE model wholesale, but thinking thoughtfully about what are the promises that the services that we're building can keep with respect to this infrastructure use as we make them available to our developers to, you know, go back to the lessons learned from Netflix. Like, we really want to unlock that product development. And so we're kind of coming to the end of this. So my kind of advice is, you know, think thoughtfully about these different services that you have to operate. Think thoughtfully about who has the accountability to operate them, who has the tools to operate them. I really like SLOs. So if you think about the way that Google's architected itself and built this up, that you have these infrastructure services, each of which have SLOs and keep promises to these platform services, right? So it's like at the bottom you have the container scheduling, you have Colossus, you have like, you know, some thoughtful things about how you're going to schedule jobs and store data and the rest of that. And then you build higher level services on top of that. They also have their SLOs that are promises kept to the kind of application and the software on top of that. And then last but not least, you have the customer facing SLOs because hopefully there's some business at some point. So advice here is not necessarily, oh, like you should adopt SRE practices, but be explicit about these models and like develop your own kind of understanding about what you're doing now. Make that explicit in a way that you can evolve it in a meaningful way to something that is quote unquote better, right? Progress over perfection. And realize that everyone's kind of in a different place on this continuum of adoption. You know, whether you're talking about SRE, DevOps, or whatever, you know, there's on the far end of the spectrum, there's lots of manual work and there's not very much monitoring, and everything's sort of done through these slow feedback loops and ticket systems. And what you want to get to is this enabled, like you build the platform to keep promises with enabling constraints that gives you the confidence that you can allow your developers to have self-service access to these systems because you can keep promises. And then, you know, that dovetails into a bunch of interesting conversations about ITIL and like these weird misconceptions about segregation of duties. And those are fun conversations to have, but we probably don't have time for that right now. So this is sort of like Andrew's simplified version of what you should think about as you're kind of adopting and making things explicit. If you don't have monitoring, if you don't have great monitoring, if you don't think you can kind of think about the 4 signals or what's appropriate for your services, that's a great place to start investing. As you build, monitoring capabilities, now, okay, we no longer have the customers tell us something's wrong. We can detect things are wrong. How do we respond to that? Be thoughtful about incident response and the way you're going to manage those, and then kind of build yourself up through this pyramid of reliability. So what is DevOps? What is SRE? I promised I would give you more questions, not necessarily more answers. Honestly, who cares? I don't honestly care. These are just words. What works is more interesting question, in my opinion. And in particular, what works for you? What works today and what could work better for you tomorrow? And then really at the end of the day, if it doesn't go to prod, it doesn't matter, production or it didn't happen, can you put code into production? And how fast? And then once you get it there, can you keep it running? So that's some questions for you. Thank you for your time. That was a quick run through some thoughts and conversation I've been having recently about how to optimize, kind of the operational practice and process around your OpenShift investment.
So it raises probably even more questions than it gives a model, which is great. And that was, I think, your plan for today, was to give us some models. But it kind of some of the conversation that I can see, and the tensions that you can see inside of organizations that are trying and struggling to adopt these models. There was one diagram you had in there that was the three-way conversation between business, ops, and development. I think there was one visual there. And when I saw that, the other thing was the other component, and you added it in later, of the customers. And what you often see is this tension inside of development groups and product management groups that are trying to deliver more features, versus the stability. And dealing with the tensions of accountability for maintaining stable and developing stable services, and in order to get that optimal goal of the SREs coming in and taking responsibility for the operation of the software services. That tension, I think, is one of the things that that you have to tease out inside of your organization, how you're going to I don't know whether it's the Pavlovian reward them for good behaviors kind of things, but that's, I think, where we see most of the tension is product managers or developers have pressures on them to deliver more features.
Exactly. So that's what it comes back down to, and really where the organizational kind of misalignment or conflict comes from is that you have executives that have slightly different compensation models, right? So it's like you have it and if you can't align that higher level mission at the top level of an org, the chance that your frontline developers and operators are going to be aligned is zero. And so that's sort of like where, so like you have to really revisit fundamental assumptions about some of those organizational power dynamics to get to these models.
Yeah.
And people's bonuses and all kinds of things. Yeah. Like if all the bonuses are tied to releasing features, whether they're reliable or not, they're going to be released.
Yeah.
People don't like it when you mess with their paycheck, right? Like that's
Yep, absolutely. I think that the reliability of your service and your software is key, but the tension of delivering, I see it every day in all of the, inside of Red Hat, in the companies that we work with, of wanting to deliver more features, more functionalities at higher scale, and that pressure to deliver more, and try not to ignore the stability of it. I think that's really, for me, the other thing that was interesting to me early on in the whole slide deck, and was the artisanal versus industrial conversation. That traditional was artisanal, and today is industrial. And then there was another one about delivering the impossible. Adrian, I think it was Adrian's quote there. And the myth, or at least the hope that I have, is that this industrial strength infrastructure and these new practices will allow us to do the creative things that we want to, right? And that allow us and empower our developers to deliver these new things, these new features, these new apps, these new services, but having the complexity of having to understand what's under the hood. So when you see someone now come to the table with a new offering, a new service, but they also have to understand what Kubernetes is, right? That's different than just having to be able to build a web application or a service or offer a database offering. So there's all this extra that you're asking developers to understand. And that's really, I think, another cultural shift. And we've seen.
In some ways, I think that's actually wrong. Like you don't, like if your developers need to understand more and more infrastructure to do their work, like it's not that you want them to be ignorant of it, but you want your developers to be focused on the creative aspect of their domain and the value they're creating, not sifting through YAML. And so like there's definitely an aspect of understanding more of the stack helps you make better or more optimal decisions for the global, but at another level, giving abstractions that are hiding some of that complexity lets you do things that you never could if everyone's worried about every layer.
Yeah, definitely. So there's a couple of.
Diane, we got a question in chat here.
Go
Sorry to interject. So Muhammad on Facebook asks, I know we only have a few minutes left here, so I know this is a long answer. How does the nature, monolithic versus service-oriented, of application impact this process of going towards an SRE DevOps culture? Any suggestions on moving a 20-year-old monolithic app towards this goal? I believe the you don't eat an elephant in one bite is kind of like a statement there, but what do you have, Andrew?
I mean, I think this is a very interesting question, and a lot of organizations are being kind of forced to ask this. So I think that you have to look at what you're trying to accomplish. And I'm not from this school of thought that microservices are always better than monoliths, right? So thinking about what kind of promises you can keep and why you want to move mindfully to these architectures is key. Now, when you think about the operating model and these tools and these other capabilities that I talked about, operations, one thing to keep in mind from the very beginning is when you go, so let's say you have an aspiration to have a microservice architecture. When you have microservices, you have more deployments. You have more things that need monitoring, right? So if you have a high fixed cost of deployment, in terms of the work, the automation that's not there, the testing, whatever, to have your confidence in the quote unquote release, or you have like these unmonitored systems, and then you go to a microservice architecture without that platform support and these operational models being changed, you actually made more work for yourself, right? So part of the microservice architecture is predicated on having these quote unquote DevOps capabilities, having these platform services available to you. Because if you have that fixed cost of deployment that's still high for each new service that you add, you actually just buried yourself in toil, right? So getting it to where the fixed cost of a new deployment of a service is essentially negligible is kind of where I would start with moving towards that architecture. And then from there, go through the hierarchy of reliability. If you don't have good, well-factored monoliths that are monitored in a meaningful way, the chance that you're going to end up with a well-factored microservice architecture that's monitored in a meaningful way is quite low, right? So let's build up that organizational competency, kind of the muscle memory around those things with the monolith that we have, and then meaningfully take pieces of functionality out of the monolith over time. Because I also think that the big bang rewrite approach to going from monolith to microservices tends to lead to catastrophic failure. So my advice, don't do that.
Yeah. All right.
Yeah, I think the synopsis there is you have to build the foundation first and then move things towards the house, right? Move things to build the new house.
It's also with a monolith, you probably can take a part of it and do that, deploy that first, and figure out the pieces of the monolith that you can break away and try the new architecture out and deploy. That's, I think,
I mean, this dovetails into like a modernization conversation, but to me, like I kind of break things into a few buckets, and if something is not causing me operational burden, doesn't need to scale to keep promises I need for my org, or doesn't have like a need to change it rapidly, right? So if something needs to stay the same, isn't a problem scaling, and isn't expensive to operate, I'll just leave it alone.
Yep.
Right.
Yeah, there's no reason to move stuff that's working just fine, right? Like unless you have some high need to do so for operational reasons.
If I want to explore some new features that are going to be, in taking advantage of the agile, whatever kind of product development lifecycle, let's move that into architectures where we can have more rapid feedback cycles with that customer engagement, right? So like that's a motivator. If I know I'm having problems keeping the reliability, the scaling of that particular architecture, let's get to the new event driven or whatever your vision is for that architecture to keep those promises. Or if it's expensive for other reasons, it's expensive in terms of human costs or licensing costs or whatever, that could be a motivator. But if it's not one of those three things, monolith for life, baby. Do it.
That's going to be the new T-shirt, monolith for life.
Monolith for life.
I don't know. On that note,
not all monoliths.
I know that it's interesting. It's all interesting. So this conversation and more conversations like this will keep happening on Fridays at this time. We'll bring more folks from the Office of the GTO and as well as other talking heads and people from this space to help you all with your transformations. And we're really glad that Andrew could join us today and make this happen. And if you want to get a hold of us, it's really easy. You can tweet at him at Little Idea, and we will post this video with his credentials and how to get a hold of him. We are also launching a transformation SIG. So there'll be a landing page soon up on commons.openshift.org with links to this video and others, as well as a place to sign up for how to join us and get announcements about who's coming on deck next. And if you have a topic you want to hear about, let us know. We will try and find someone to talk about it or make you talk about it, which is even more fun.
Yeah, come on and talk with us. That'd be fun.
Yeah, so definitely do that. So thanks again, Andrew, for joining us today.
Thanks for having me.
It's just a pleasure, and lots of food for thought there. And so take care and have a great day.
Stay safe out there.
All right. Stay safe, everybody.